Alright, kind of a short one today compared to the last few, but congruence transformations. Alright, so the first couple problems, it's just going to give you a couple graphs, and then there'll be a bunch of shapes in the graphs, and it'll just say like which ones are congruent. So remember, congruent means the same size. So to look at, and they want you to kind of, and I'm not necessarily concerned on this one with this, but so if you had say 3, 5. Yeah, let's say this was like A, B, C, D. This was E, F, G, H. So the directions will say identify any congruent figures in the coordinate plane and explain. And so the explain part is wanting you to describe the transformation. So first you kind of would want to check, okay, yeah, these are all have the same like length. My spacing's a little bit off on my like tally marks, so but you could say that A, B, C, D is congruent to E, F, G, H. Now, you do need to be careful that you follow the right order. The first one doesn't matter, so A, B, C, D, you can write that one in whatever order you want. But A, I think, hopefully clearly, goes with E, B goes with F, C goes with G, and D goes with H. You have to, I mean, I wrote it in alphabetical order, but make sure that you follow those. So if I were to switch the G over here and the H over here, then in my writing I'd have to say E, F, H, G. So you do need to make sure that you follow the same like order. And there's not a correct way to do it. If you started with and you said D, A, B, C, and then you followed G, E, F, H, that's fine. So there's not like a has to be this way or that way. So then it says explain. Well, the explanation is they want you to write, what the transformation is that made it from one to the other. So the way that, like, when they look the same, they're what I call oriented the same way. Now this is a square, even though the ABCD doesn't look like a square because of my marks are messed up. There really isn't an orientation like change. But how did I get from A to E? How did I get from A to E? Well, I went -2 because I went left 2, And then I went down 1, 2, 3, 4, 5, 6. And if you looked at any of the other ones, you would do the same thing. So if you went from D down to G, you went down 1, 2, 3, 4, 5, 6. So your explanation would be a translation rule. -2 in the x direction, -6 in the y direction. Okay? So when they're, you know, a square or something like simple, it's a little bit easy to see, like, is it a translation? Okay, so this would be a translation. All right. So you could have put that in the wrong spot. Okay, so if you look at this one, you know, like, it's not, they don't look the same right now. Like, you know, AC is a flat edge, and then really the flat edge on the other one is DF, you know, so the DF is going up and down and the AC is going side to side. So it's not going to be a translation, because a translation, it would look the same just in a different spot. So if it was a translation like of the ABC one, let's say, then, like, you know, over here it would, you know, it looked the same just in a different spot. So that one doesn't look the same. So that means we got to do either a reflection or a rotation. And so the easiest way to tell is, you know, a reflection would look similar, just like backwards, if you will. So a reflection, you know, could look like this. Well, it's just upside down. Or it could look, you know, if you flipped it over to the other side, it would look similar, where this one looks like it's definitely turning. Okay, and so you can see, like, kind of what I notice is, like, from like the origin, if I go to C, I go 2 to the right and then 1 up, or I go 2 and 1 that way, or 1 and then 2. Okay, so there's a similar how did I get there kind of thing. So to get to A, you know, I go over 1, 2, 3, 4, 5, and then up 1, or up 5 and over 1. So I still have that 5 and 1 relationship, okay, and that will happen with a rotation. Okay, so this one is a rotation 90 degrees because we went from one quadrant to the next. Remember, so going from like here to here, this would be 90 degrees. Then from there to there, it'd be 180 degrees, 270 degrees. So just, each quadrant is another 90. But it would be a rotation of 90 degrees about the origin. And you could say that triangle ABC is congruent to triangle DEF. Okay? Alright, and then I have a couple that are a combination. Okay, and so it'll say describe transformation from A, B, C, D to E, F, G, H. So when I'm done, the A, like I'm going to slide, I'm going to translate it, I'm going to rotate it, I'm going to reflect it, I'm going to like do two of those things, like whatever. But the A needs to end up on the E. Okay, and like the B needs to end up on the F. So right now, again, they're not like oriented the same way. Like the top one kind of slants to the right and the bottom one like slants to the left. So that means I got to do either a rotation or excuse me, a reflection. Okay, and so what I notice is if I reflect it this way, so the A is 1 to the right, so go 1 to the left, and then 1, 2, 3 for the B, 1, 2, 3 for a new B. C is 4 to the right, so go 4 to the left, and D is 2, and I go 2. And then, like what I also notice is that if I just slide this down, the A matches with the E, the B matches with the F, the C matches with the G, and that's what I want. So I did a reflection over the y-axis, and then if I slide it down, 1, 2, 3, 4 spaces. So if I do a translation, so here's kind of a weird one. I'm not moving it left or right, so it's just X. And then I went down 4 in the Y direction. And you could count 4 from each of those different points. Okay, so some of you, depending on what your eye sees, might have said, well, what about if I reflected it down? Because now it looks like that one. You know, like it looks like that one. The problem is, based on, if you go back over here to the right, I need to match the A with the E. Well, the A and the E from the green one down to the bottom, like the A is up here on the top left hand corner and the E is down here on the bottom right hand corner, and so it just, like, you know, you could do it, it just creates a much bigger problem. Okay, so sometimes the reflection, well, do I do this way, do I do this way? And you really got to pay attention to the letters that you want to line up. Okay. All right, so the first section of problems just has some picture, you know, has a bunch of different shapes on it. How do you know they're the same? Try to come up with or how do you know they're congruent? Try to come up with a transformation. Then the next group, it'll say describe, just like I just did, describe a congruence transformation that maps the blue to the green. Okay. And you might have to do more than one, like I just did on this one. Okay. Or you might only have to do one. It just depends on the problem. Okay. And then the last group of problems, it'll say determine whether the polygons with the given vertices are congruent. Use transformations to explain. So put the two, like they're, you know, the first problem in that group is a triangle. Draw the two triangles on a graph and then see if they're congruent. Okay, and if they are, then say, oh, that's a translation, or that's a rotation, or that's a whatever. And if they're not, just say, well, like, say why they're not. Well, if I translate this one, it goes 2 and then 2, but that one goes 2 and then 3, so it doesn't work. Okay? More of them should work than not, so just keep that in mind. All right, so nothing really new, just using them in a different way. Okay? All right, have a great rest of your day, guys. We'll see you tomorrow.